Hello and welcome to Naughty Daddy's Guide to Computing, from mathematics to Minecraft. We're going to ditch the binary arithmetic for a little while and we're going to talk about logic. Now, sometimes we think we know what logic means. It means something that makes sense or a reasonable or rational argument. I think we've largely got Mr. Spock in Star Trek to thank for that concept. But in this case, logic is a formal set of mathematical rules for dealing with statements and evaluating statements. The kind of logic we're interested in computing is called Boolean logic, after a mathematician called George Boole. And this is Boolean logic. It dates all the way back to 1847, long before the invention of the electronic computer. And in fact, without Boolean logic, we simply wouldn't have an electronic computer, we wouldn't have the internet, we wouldn't have Twitter, we wouldn't have Minecraft, we wouldn't have YouTube. Now this Boolean logic, it uses words that we are very familiar with in the English language. So this can be a little bit complicated because you're using words that you know intuitively what they mean. And the problem is they don't necessarily mean exactly how we understand them in normal English. So the words that we're interested in here is not, and or. And you might say, well, silly daddy, we know what not, and or means. But in Boolean logic they have very precise definitions. In Boolean logic there are no grey areas, there's no ambiguity, there's no, well, it depends on your school of thought or matter of opinion. A statement can only be evaluated as true or false. In fact, I'm going to write T for true and F for false. And with not, if it's not true, it must be false. And if it's not false, it must be true. There is nothing in between. So we define our not with what we call a truth table. And let's say we have statement, which I'm going to call it statement A. Let's, for argument's sake, let's say statement A is rain falls up. And I'm going to say the not of A, which we write with a line above the A, not A, is basically rain does not fall up. So statement A, rain falls up, is false. So not A, rain does not fall up, is true. Let's say another statement. Let's say statement A is the sun is hot. That is true. So now we're going to say the not of A. The sun is not hot. That is false. In Boolean algebra, you really don't have any arguments. There's no in-betweens. A statement is if a statement is not false, it is true. If it is not true, it is false. That is our definition of the word not when we deal with Boolean algebra. So it's better to actually memorize the truth table than try to think of ways using the English equivalent of not. With and has two inputs, so we deal with two statements. So statement A and statement B. And we write A and B with a dot. A dot B is A and B. And the definition of and is a statement is only true, or the and function is only true if both statements are true. So let's say rain falls up, and the sun is cold. This is false. Both statements are false. A and B is false. If we say the sun is cold and rain falls down, that is also false. The fact that the sun is not cold negates, it doesn't matter that rain really does fall down, the and condition is not fulfilled. Rain falls up and the sun is cold, that would be false. Let's take rain falls down and the sun is cold. It only takes one condition to be false to make the whole thing false. Let's take the last condition. Rain falls down and the sun is hot. Both conditions are true, so the whole statement is true. This is our definition of and. It is only true if both statements are true. And lastly, let's look at or. So we have our statement A and our statement B, and our statement A, we use a plus sign to make or, A or B. Okay, so statement A is false. Let's say the sun is cold. Statement B is rain falls up. Both conditions are false. So either the sun is cold or rain falls up. Well, that is false. Both conditions are false, therefore it is false. Okay, rain falls up or the sun is hot. Now, in English, we might say, well, that's still a bit of a false dichotomy. It doesn't necessarily follow that just because rain falls up, just because it's false that rain falls up doesn't mean it's true that the sun is hot. It doesn't necessarily have to follow. However, in Boolean logic, we're not interested in whether one statement implies another. In this case, with the or function, it's simply a case of if one statement is true, the whole thing becomes true. And this is why it can be a little counterintuitive. Okay, with Boolean logic again, if statement A is true and statement B is false, say rain falls down and the sun is cold. The rain falls down or the sun is cold. That is true. One of the conditions is true, therefore the whole thing is true. And lastly, rain falls down or the sun is hot. Yes, it's true in English language, one does not imply the other, but in Boolean logic, if one statement is true, the whole thing is true. So this is why we have to be careful when we deal with Boolean logic. We don't just let our own natural English language interpretation of a word get in the way. We have to say these operations in Boolean algebra or in Boolean logic, these have very strict, rigid definitions, and we can evaluate based on those truth tables, such that these truth tables form the very definition of our words. Okay, in the next episode we're going to look at combining these logical functions and maybe trying to use them with some binary. See you in the next video.